Right, we have a two-figure number, and I've decided to call my two-figure number AB. What do we know? We know that if we add A plus B, we get the number 9. So even though we know that this is really a number of tens, and this is really a number of units, ones, okay? So it's a two-figure number like 25, 36. There's a 10 unit and there's a 1 unit. So we know that if we were to add A and B together, we would just get the number 9, ignoring the fact that A is 10 times larger. So when it says siffersumma is 9, it means you ignore the fact that this is actually 10 times larger. So A plus B equals 9. And we know that the number AB, we don't know what the number is yet, is less than 81 but greater than 18. But what do we know? The value of A. But we know that the value of A is 10 times whatever A is. If this number was 18, A would be 1, but the value of A would be 10. So 10 times 1. So 10 lots of A equals 5 lots of B. So we can solve this algebraically. But what would we do if we couldn't solve it algebraically? Let's think of which two numbers, if we just added A and B together, would give us 9. Well, we could start with A equaling 1 and B equaling 8. Or we could have that A was 2 and B was 7. This would give us the number 18. This would give us the number 27. And then we just carry on. 36, 45, 54, 63, 72. And it has to be less than 81, so it can't be 81, and it also can't be 18. So that we know that our number has to be one of these numbers. Then we look at our numbers and say, okay, if we took the actual value of A, which the actual value of A here is really 20, 30, 40, 50, 60, and 70. And we looked at, is there any number where A is 5 times larger than B? 7 times 5 doesn't give us 20. 6 times 5, 6 times 5 gives us 30. 5 times 5 doesn't give us 40. 4 times 5 is... So we found the one that is giving us that the number of A, the value of A, is 5 times larger than B. Okay? So we know that our number has to be the number 36. Little check. Does 3 plus 6 equal 9? Yes. Is the value of A 30, 5 times larger than the value of B? 6. Yes, it is. So that's how we would do it, just using different numbers. How we could do it algebraically, because we now have our equation here, is that we know that A plus B equals 9, and we know that 10A equals 5B. So we know then, if we rearrange this to get what A is by itself, A must equal, and we would divide both sides of the equation by 10. A by itself must equal B divided by 2. Or we could also have that we could have divided both sides by 5 and got that 2 lots of A equals B. And it doesn't matter which one you do here. So these are your starting equation. This is your equation 1. And this is your equation 2. Now, if every time I see B, I know that B equals 2A. So I go back to my first equation. Here I have an A. And here I have a B. And instead of writing that B, I know that B equals 2A. So I put 2A here, because I know that B is exactly the same as 2A. So A plus 2A must equal 9. A plus 2A equals 3A. So I know that 3 lots of A must equal 9. Now I can work out quite easily what 1 lot of A is by dividing both sides of my equation by 3. So 1 lot of A is 9 divided by 3, which is 3. Now I know that A equals 3. What do I get for B? Well, I know that A plus B equals 9, and I know that A now equals 3. 3 plus B must equal 9, therefore B must equal 6. So you can do this by setting up the table of numbers and trying to find the one that works, or you can actually solve it algebraically as well. This type of question. Okay?